Hi, I'm at the United States Space Walk of Fame here in Titusville, Florida. We're located on Pine Street in downtown Titusville. One thing I'd like to point out that this is a historic, National Historic building. It was a registered part of the courthouse, the clerk building, and it was 1903, and it's established this building in 1903. I'm standing here before the Space Launch System. But the key to the Space Launch System is two items that I want to point out to you. Here is the external tank, and here is what we call the orbiter. The unique thing about the orbiter that President Nixon of the United States signed in 1972 is that it is our only, and it was the first reusable spacecraft. But what makes it unique is this history here. This building was in 1903. In December 7th, 1903, about 450 miles north of here, in Kitty Hawk in the Carolinas, two brothers, bicycle builders, Orville and Wilbur Wright, launched the first heavier-than-air aircraft. In 2003, January, this shuttle launched. Now, it was a tragic launch. But the point I'm trying to make is that in 2003, we're comparing two vehicles compared to 1903, 100 years difference. In 1903, the first flight on December 7th was 120 feet distance. They sailed at 6.3 miles and about a 20-mile headwind. Their height, 10 feet. Now we go in time, 100 years to January 2003. Here we have the external tank. The external tank from bottom to top is 153 feet. 100 years before, they flew 120 feet. That means that the first heavier-than-air plane did not go the distance of this tank, which is 153 feet. They did two other flights. One was 200 feet, was certainly past this tank. I mean, the second one was 175 feet, and the next one was 200 feet. But now, 100 years later, January 2003, instead of just going 6.3 miles an hour, we have a vehicle that can go 17,500 miles an hour in 8 minutes. Not only can 100 years later, you had just one pilot and that's all it could take. We have a vehicle that can take 7 people and carry 25 tons in 100 years. Not only that, but consider this, my friend, that the advancement of such of these things, such as that the Wright Brothers went 10 feet high. Well, this was able to launch the Hubble Space Telescope 350 miles. This orbital system is limited to about 380 to 400 miles. But 100 years prior, they went 10 feet. So 100 years later, not only did we go further than 10 feet, with this vehicle we went 380 miles high. And we built the International Space Station that sits at 250 statute miles as far as this date. And for 15 years, we had a living presence. Those that were born and are 15 years old or younger, or maybe 10 years old and younger, never had a time when there was somebody living in space because of Ronald Reagan and Glasnost saying we're going to build an International Space Station with Gorbachev. But the Wright brothers was not a stunt. They had data, they had wind tunnel analysts, and here we have the shuttle in 8 minutes. Instead of going 10 feet, it goes from 0 to 380 miles up, and it put one of the greatest instruments in space, and that is our National Observatory, the Hubble Observatory Robotics. It's a robot, remember that.
Can we go take a look at the Hubble exhibit?
Yes.
Cool.
Did you want me to continue?
Yep.
Was there no ring?
Yeah, this is great. We got 5 viewers.
You sure that was okay?
That was great.
Okay. Here is my most favorite instrument of all times. The Hubble Space Telescope. Now, it wasn't the first time somebody thought about putting a telescope in space. Actually, it was proposed in 1914. And in 1914, World War I started in Europe, and then we joined in 1916. It's amazing how war and exploration always are opposite of each other. Here we have the Hubble Space Telescope, many repair missions. Actually, one of the repair missions had to use Endeavour. Now, the Endeavour shuttle has a little bit more fuel in it. But they found that when they went up for the repair mission and all the things they have to do, because when they join the Hubble to the shuttle, that changes the mass. So you got to maintain your orbital pitch and maneuverability and everybody with the arm. So when they came back, their fuel was very, very low. And the shuttle Endeavour is the only one that has a little more fuel capacity in the own pods. Here's what I wanted to point out. The unique thing about the Hubble Space Telescope that was incorporated is that the Hubble Space Telescope greatest attributes is that it's an ultraviolet telescope and an infrared telescope. See, the problem is that the Earth itself reflects out a lot of UV or ultraviolet light, which we don't want a lot in, of course. On the other side, on the infrared, the Earth absorbs it, okay, and doesn't reflect it back, or it absorbs it. So the thing of it is, we need to find out beyond our just optical eye view what was out there, and that's one of the greatest things. Why? Because the Hubble mirror was coated so that it could be utilized for ultraviolet and infrared, because that was a key thing of being in outer space. Today we have observatories with adaptive optics that can sort of meet it, but they cannot see the infrared here on Earth or the ultraviolet definitely here on Earth. So it's still a wonderful national observatory. I'd like to point out this. The greatest discovery was things like this. This is one of the best, and it's considered the 21st century astronomy. We're not in no 20th century like with Hubble and Wilson's, and all that is important, but we're talking about the millennium. And this ushered it in. Why? Because we were able, the world was able to have eyes 13.7 billion light years out. So it's like placing your eyeballs 13.7 billion years from where we are. This is the Whirlpool Galaxy, M51. It is actually 31 million light years away. You will have to travel at the speed of light for 31 million years in order for you to be present before this present galaxy. And the reason why it's so brilliant and so nice, because it's a face-on galaxy. Now, the thing of it is, I'm going to put it back. Sorry, I wasn't supposed to do that. We discovered many other things like the Helix galaxy, nebula, an exploding star. Other things like we got the Starburst galaxy, M92, brilliantly depicted. Here's the point I'm trying to make. There was in the 1880s a scientist that said, what can you tell from the stars of light? We had telescopes now, we were seeing planets. There's no more we can learn from these light bodies. Well, he was very much wrong. Because with spectra, with breaking down the light, we can find out what is the material made of. By seeing the Doppler shift, we can follow any changes that it makes. Secondly, with the information presented here of the gases and a dying star. Third, Hubble revealed the birthplace of stars. So in other words, you got stars actually being born next to a picture of a star actually dying and blowing away as it runs out of its fuel. The two sides of how our universe works and how we're able to be here. But don't forget, we only know of 4% of the visible universe. We still don't know about 72%. And as the earth is like 70 or 70% water, just think of it. We have this water and we have no idea what it is. We can go out there and swim and see things over here, but we don't see it, it don't interact. So there's so much more that we need to learn, so much more we need to do, so much exploring that we should be doing, and not having so much war. I like to emphasize that Hubble, the namesake, back in the turn of the century that we have here, he was the first, because at this time we only knew of the Milky Way. Well, Hubble set his sights on finding out about what they call the puffs in the sky, the little blips in the sky that wasn't stars. Well, he set out to look at it, and he discovered they're moving away. He discovered that everything's moving away. And he continued to notice two things. He began to measure the distances of these galaxies. How did he could measure the distance? Because we have lights. Now, as you well know, if you have a car light that's further away and a car light that's closest to you, that there would be a difference in brightness. The problem is you have to know how bright the car light is. So in other words, the car further away, if you knew how much luminance that it was exhibiting, or how much energy, how much light photons it was showing, and you knew the car closest to you, how much light it was exhibiting, and there was a standard that you can go by, you can accurately judge the distance. We can do it by our eyesight because we generally know how headlights are, correct? But at this time, we didn't know the distance. So what they looked at was the nebula, an exploding star. We call it a standard candle. And we know exactly how much energy is because we know its mass and its movement. He used that as a light reference, therefore he was able to judge distances. And through that judgment of distances, we found out the vastness of it. And then, as you know, if you hear a train come by, the Doppler effect. And we use it on our radar with weather. So in other words, if you have a wave coming towards you, then the wavelength to you compresses and becomes shorter, so you have a higher tone. Then as it leaves you, the wavelength of sound expands. So you get a ooh, ooh. Well, it's the same thing with these moving bodies, but we measure light instead of sound. So as it moves away from us, the wavelength of light stretches, so it tends to be red. As it moves closer to us, because all of this is moving, then it tends to be blue. And that's the Doppler effect. And with that, we can estimate the velocity, we can measure the mass, and many other elements. And it's all because of Hubble here doing that with a telescope observatory at Palomar. He was there, and that's what he discovered, and that's why this telescope was named after him. But one of the facts are, NASA never names anything until it actually gets into space, as you know, because they always give it like a model number or a stage or abbreviation. It's not until it's actually in orbit that it's actually christened with a name. And therefore, it was christened Hubble because it was thought of to be successful. And there was 3 other Hubble repair missions. And it sits 380 miles up on a declination of 28 degrees to the equator. And it's still working now. The problem is, how do you point such a telescope to be accurate? We have what is called the deep field. They looked around where the Big Dipper is, and if you ever notice where the Big Dipper, which is part of Ursa Minor, is sort of like an empty space. So they took the Hubble, and they said, we are going to look at a completely empty space and see what we can see. And they took it to that empty space. And they exposed this exposure for days upon days, leaving it open. But how could they do that? That's because the Hubble Space Telescope has gyros in it. And that's what's used for fine pointing. Take a bicycle wheel and take it in your hand and spin that bad boy. It maintains a reference, right? Spinning, spinning like this. So take another one and spin it. And take one by your head and spin it, just like what they do with them plates in a circus. Well, the thing of it is, if I make this gyro move like this, just slightly slow it down, and this gyro move, and the gyro by my feet slightly move, I could wobble. I could wobble over. All I have to do is control the speed of my bicycle wheels, right? They're turning very fast. So if I slow down this one, the inertia of this one will move me over here. You know, I could do a dance. If I slow down this one at the top of my head, I could tilt. So Hubble has 6 gyros in it, but they started failing and they replaced it. What else got gyros? The International Space Station. Its fine pointing is by gyros. They have thrusters to get out the way, but the fine pointing is more efficient when you use gyros that can move. What is that like? Well, take a washing machine. Spin that bad boy, but off spin the weight, and that thing will wobble. The thing of it is, spinning bodies have properties. This has 6. During the repair mission, at minimum you need 2. By the time they got there, there was only 3 working, and that one was spotty. But that's how you get these pictures. Because if you had a camera and you shake it, you know what I'm saying? What kind of picture are you going to come up with? So that's why the gyro system was very important with the Hubble, is that it maintained a precise, and they were able to hold that exposure to that empty space for days, and they seen nothing but galaxies. 100 billions of galaxies with 100 billions and billions of stars in one empty space, because they was able to maintain that telescope at a pointing position, and they went all the way. What can we see if we go all the way out and let all the photons come in? And they did it for days. I forgot how many days. You gotta check your facts. But for days upon days, they just left the shutter open. And that picture is called the Hubble Deep Field. Please look at it. You will see there's nothing but galaxies. If you do see a star, it's super bright. But there's nothing but galaxies in it. Hundreds of billions of galaxies. And I think, in many ways, as an amateur astronomer, this is a delight for me, and I'm glad to share it. There's one last thing. It's not only what's unique. If you look right here, right at the top, the astronaut went up there. Those are called magnetometers, and they read the magnetic field. And the thing of it is that they have 2, one on each side. Our Earth has a magnetic field, and we have an active planet. So with the magnetometers, you can get position. Consider it a complicated compass. Like, you can take your compass almost anywhere, and what? It points north. So if you know where north is, you can know where east, west. So the Hubble has 2 magnetometers also for pointing and general reference. And it's orbiting, and it's a wonderful thing. So between the shuttle, 100 years from the Wright Brothers, heavier than air, to where we're 17,500 miles an hour, 380 miles up, we built the International Space Station, which has been people have been living on it for at least 10, 15 years, to even where we have the Hubble with its magnificent discovery that right now it brings our eyeballs 13.7 miles to the edges of what we consider the universe. Wait until Webb. Webb is going to be different. The downside is, because the shuttle is only 300, can only go about 400 miles up, we have a lot of Earth shine in that telescope. So the Webb is going to be out on the Lagrange thing. They're going to be about 1 million miles out. So it'll be a stellar orbit type thing, because we get a lot of light reflection from the Earth. But it was the shuttle that got it there, and it worked the work, right? So I hope that helps everybody. And this is the United States Space Walk of Fame Museum in Titusville, Florida, located on Pine Street, And please visit us. This museum's here for you and the world.